The next question that we'll take is, find the equation of line on which the length of perpendicular from origin is 2. Always remember, the basic hint is whenever you are given the length of perpendicular from origin, straight away think of the normal form. Either you are given the length of the perpendicular from origin or the slope of the perpendicular from the origin. In either of the case, think of the normal form. As we had discussed in the case of intercept, whenever you are given intercept, if you find the word intercept in your question, look for the intercept form. Whenever you are given the length of perpendicular from origin, always look for the normal form. Okay? So in this question, what is given? Find the equation of a line on which the length of perpendicular from origin is 2. Now what is 2? P is 2. What is P? P is the length of perpendicular from origin. Therefore we know 2. If we can somehow find alpha, we will be able to write our equation x cos alpha plus y sin alpha is equal to P. Now another information is, and the slope of this perpendicular is 5 by 2. What is it telling you? It is telling you, suppose this is our line, this is the perpendicular from the origin, and this P is what? 2, and the slope of this line, is what? 5 by 12. Now one thing you will have to understand in this question is, if M is 5 by 12, is this the only possibility that we can have? Is this the only line that we can draw? Because M is positive. M is positive means tan alpha. If this angle is alpha, tan alpha is positive. Now tan alpha is positive not only in the first quadrant, but it is also positive in the third quadrant. Therefore our line could also be like this. The condition will still be met. This length is what? The perpendicular distance is still 2. This angle would be alpha. And again, since alpha is in the third quadrant, tan alpha will come out to be positive. Therefore, again I am saying, the basic knowledge of trigonometry is very important in this case. Therefore, obviously we will have two answers in this question. One when alpha will be acute, and the other one when alpha will be in the third quadrant. Now the slope of the perpendicular is given to be what? 5 by 12. That is, tan alpha is given to be 5 by 12. Now go back to your trigonometry part. Let's say this is your right angled triangle. This is alpha. Now tan alpha is 5 by 12. Therefore this is same as perpendicular upon base. Therefore this is perpendicular and this is base. What will be the hypotenuse? Hypotenuse would be 5 square plus 12 square. This would come out to be 13. Now for our equation, what we want? We want cos alpha and sin alpha. And we have already realized that there are two possibilities in which tan alpha can be positive. So the first case is when tan alpha, or rather alpha, lies in the first quadrant. If alpha lies in first quadrant, tan alpha would be positive. Tan alpha is positive. And through this, we can find out cos alpha and sin alpha. And sin alpha, cos alpha will also be positive because alpha is in the first quadrant. What is the value of cos alpha? Base upon hypotenuse. And sin alpha would be perpendicular upon hypotenuse. Now our equation becomes x cos alpha, that is 12 by 13 x. Sin alpha is 5 by 13 y. And p we already know, it is 2. Therefore our equation is 12x plus 5y is 26. Now the second case could be when our alpha lies in the third quadrant. If alpha lies in the third quadrant, tan alpha will still be positive. And in that case, cos alpha and sin alpha will have the same values, numerical values, but their sign would be negative because cos alpha and sin alpha in the third quadrant are what? Negative. Therefore, instead of 12 by 13, we'll write minus 12 by 13 and minus 5 by 13. Therefore, our equation now becomes minus 12x by 13 minus 5y by 13 equals to 2. And in that case, minus 12x minus 5y is equal to 26. We'll take everything to the left side. Therefore, we get 12x plus 5y plus 26 is 0. This is your other equation that is possible. So always remember then that whenever tan alpha is positive, you have two cases. Either alpha lies in the first quadrant or alpha lies in the third quadrant. In that case, cos alpha is also positive, sin alpha is also positive. In the third quadrant, cos alpha would be negative as well as sin alpha would be negative. Similarly, if you find that your tan alpha is negative, tan alpha is negative in which quadrant? Second quadrant, or rather we should write alpha lies in the second quadrant or the fourth quadrant. Now if alpha lies in the second quadrant, cos alpha would be negative, but sin alpha would be taken positive. In fourth quadrant, cos alpha will be taken positive, but sin alpha will be taken negative. This you should remember. Whenever you are given the slope of the perpendicular from the origin, that is alpha, then these are the possible cases. I hope you have understood the question.